Hello everyone. In this session, we are going to learn about Node MCU. Nowadays, Node MCU is very much helpful in designing and developing various IoT projects, products, and prototypes. This is very much useful for students, researchers, engineers, and hardware professionals. As we know, the IoT architecture from previous module, which includes node, network, and cloud. You may wonder in which section this Node MCU actually falls. This is the Node MCU IoT development. The node actually collects various sensor data, for example, temperature data, humidity data, etc. And node can also control the actuators. The actuator performs various tasks. So, in general, the node is doing two things. One is collecting data and the other is controlling the actuators. So, we need to connect the node to the network using some communication protocol. Maybe some Wi-Fi connectivity or Ethernet connectivity or Bluetooth connectivity or any other means. Node can be connected to the cloud through network. Once the node get connected to the cloud, it can send data to the cloud as well as it will receive data from the cloud. Data transfer can be bidirectional. For example, suppose we want to display some sensor data in some mobile application. In such case, suppose the temperature data will be carted locally in node and then this data will be sent to the cloud through the network. And how within the cloud you have this temperature data? This data now can be displayed in web application or Android application, or it can be stored in some server. From cloud, we can visualize the data, we can analyze the data and lot of other things that can be performed on the data. Then the question is, where is Node MCU in this? So the Node MCU is generally used in node design process. What is node design? Node is the end device which interacts with the physical environment. It can measure and control. Node design consists of microcontroller, sensors, actuators, and connectivity. Here you can see the node design. It includes the microcontroller, the sensors, the actuators, and some kind of connectivity. For designing a node, we require this minimum requirement, that is microcontroller, sensor, actuator, and connectivity. So, Node MCU, why we use it for node design? The answer is Node MCU comes with the connectivity module in bit itself. It is already having a connectivity, that is on-board Wi-Fi module. It is having 32-bit 10 silica microcontroller as well. So the microcontroller and the connectivity both are available in Node MCU. Again, it is having GPIO, that is general purpose input output digital pins. Generally, digital pins are used to connect sensors, actuators. So in Node MCU we have all the requirement for node design. We are having GPIO pins, which is required to connect the input and output pins or the digital pins to the sensors and actuators. Also, we are having one connectivity module, that is Wi-Fi connectivity module inbuilt in the board. Again, now come to the Node MCU hardware part. The Node MCU is a low-cost open source IoT platform which is used by various commercial companies to build their automation product. Node MCU main hardware is based on ESP12E, which is ESP8266 module. Now this is open source, anyone can design this. It uses 802.11b/g/n communication technology. To store the program and data, RAM and flash memory is also available. 128 KB RAM and 4 MB of flash memory is available with the Node MCU board. Apart from this, it is having GPIO pins and analog to digital converter. To read sensor data, we require ADC, that is analog to digital converter. It is fully programmable. It has different communications like I2C, SPI, and UART communication. It supports communication devices. We can program this node MCU using Arduino IDE. MicroPython can also be used to program node MCU. To work with sensor and actuators, the interface we need is GPIO or digital bidirectional pins. These pins are used to monitor different parameters like temperature, humidity, etc. GPIO can read sensor data. It can also write the digital signals out. We can control LED, motor, servo motor, etc. Now come to the main hardware on the node MCU board. If you see, you can have a USB connector over here through which we can connect to the laptop or computer using USB cable. Power to the node MCU board can also be done through this USB connector. It also uploads the program to the microcontroller. Here there is a button which is known as reset button or RST. If you want to run a program from the beginning, then it can be pressed. The brain of the development board is ESP12E, that is ESP8266 SoC. SoC means system on chip, based on system on chip technology. It is having Wi-Fi and microcontroller inbuilt. It is having also one ADC module inbuilt. This section is known as the antenna. Another important IC is there, that is CP2102, which is USB to UART bridge. Through this, we upload program to the board. This is the section, or this is the chip that is known as CP2102, through which we can upload program to the. This is the voltage regulator. It converts 5 volt to 3.3 volt because node MCU works with 3.3 volt. This ESP8266 based SoC requires 3.3 volt for operation and also logic voltage of 3.3 volt. It actually works with maximum 3.3 volt operating voltage. Now see, there are digital pins or GPIO pins D0, D1, D2, D3, D4. Again 3 volt 3 ground D5, D6, D7, D8. So these GPIO pins control actuators like LED or motor or any other actuators. There are 9 digital pins. We can interface sensors with these digital pins. It works with 2 modes. One is input mode for sensors and other is output mode for actuators. These digital pins should work as output mode for actuators. So output pins can write data. Input pins can read data inside the microcontroller. Apart from these pins, digital pins, we are having power pins, that is 3 volt 3 and ground. There are 3 volt 3 and ground pins in pair. Here it is 3 volt 3 ground, again ground 3 volt 3, again there is ground and 3 volt 3. There is a V in pin over here, ground and V in. This V in pin is used to power the board by a DC source or battery. Suppose if there are analog sensors, microcontroller cannot directly work with analog sensors, so we need to convert them to digital. Pin A0 over here one analog pin is there. This analog pin can read an analog voltage and convert that into ADC values. Those ADC values can be read in microcontroller. We can generate variable voltage using digital pins. Using PWM technique, all the digital pins are PWM enabled. So, this is all for Node MCU hardware description. In the later tutorial, we will discuss about how to install the ESP8266 module in Arduino IDE. Thank you. See you in the next tutorial.